Hey boys and girls, Mr. J here, out in the wild. I want to talk to you more about trees and some tree rings. How every year that a tree is alive, it puts on a new ring. But first, that tree right here, it's a conifer, so it's evergreen, and it's called a hemlock. And your conifers have modified leaves in the form of needles. And in a mountain environment, they will win the battle of who gets to have the most because they have a longer growing season, where the aspens and some of the other trees, they have to wait till the leaves are present before it's producing photosynthesis. The conifers, once it's above freezing, they can begin to produce food for the plant, and that allows the plant to grow quickly, and will, in that environment, will beat out your deciduous trees. And deciduous means that it loses its leaves. We also have non-deciduous trees like your conifers. And not all conifers are trees. And we talked about a tree having a woody stem, but shrubs can have herbaceous or woody stems. But a yew is an example of a shrub that has a woody stem, and it's a conifer. So it has needles instead of leaves. And remember, your pine needles, your conifer needles, are a modified leaf, just like thorns are a modified leaf. But you can see the pattern there. And each conifer is going to be different, how it's arranged. The Colorado blue spruce we saw had a different arrangement. I have a tree here that was diseased. And, well, here, let me show you. It was big. I mean, here's my hand, and show you how big it is. And every year that it was alive, it put on a new layer on the outside, and it pushes the bark out, and the bark cracks, and it's like putting on a t-shirt that doesn't fit you anymore. But the outside layer is where the tree sends its nutrients up and down. That's your xylem and your phloem. And the early settlers, when they were wanting to farm, they would do what's called girdling a tree, and they would cut around the outside within an inch or two, and it would kill the tree while it was still standing. Another benefit of that would be if you wanted a wood to burn, it wouldn't be on the ground getting soggy. But we figured that out. Some vines will girdle trees, large trees in the forest, and will actually take them down. But this one here, so hopefully the camera will show there's a line. On good years, it'll have bigger space between the lines than on years that there's not a lot of moisture. And when we were talking about the tree video, we talked about a tree falling in the woods and making a clearing. Sometimes there's been small trees that have been living there, and they look like, oh, they're only a couple of years old. Some of them are 15, 20 years old, and they're not that big around. They just haven't been able to grow that much. And so I learned this on a tour in Wisconsin of the forest. So when those trees do come down, the new ones that have been around for a while that don't look like they're that old, they're actually quite old, and they'll get big rather quickly. And some of those rings you'll see huge growth years, and you can hypothesize that a big tree went down and made a clearing and allowed the sun to get in so it could win the battle. So this tree here, I wish we could see the rings better. Here we go, there's a bunch of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 23, 24. I'm only 24, and I'm only this far into the center. So I could say if that's 1, 2, 3, I bet you this tree was 75 years old. That's just an estimate. I could sit here and count them, but I don't have all day, and nobody wants to do that. We could count them, but using an estimate of taking part of it and then dividing it up, which is what we did. It's approximately, if we counted 24 rings, call it 25, round it up, and then I took 3 sections of it, so 1/3, 1/3, 1/3 to get to the center. So that's an old tree. That's a little older than Mr. J, just a little bit. So that's more on trees. So next time you look at a tree, think about that. Look at the texture of the bark. Trees are often identified by the leaf and by the texture on the bark. And one of the other things I find really neat about trees and about people, if you were to close your eyes and you were in front of a bright light, you would see a pattern. And if you look, the veins on the plant would have a similar pattern as your capillaries and your eyes. And the other place we see this pattern is in the root system. And the root system spreads out to capture the water. The leaf spreads out to capture the oxygen, because on the underside of the leaf is where the air exchanges and the pores of the leaf. But also when we look at a tree's design, the apical dominance we talked about, we see that same design that we see in our capillaries of our eyes, in the root system, in the way that a tree reaches to the sky. And in the same way, our entire arm has all of these capillaries, this network that goes from bigger to smaller, just like a tree goes from bigger to smaller. We have our arteries, they have their big trunk. We have our major artery that goes back to our heart. There's that hemlock. And the branches get smaller and smaller and smaller. And that bottom one is reaching out towards the sun because he wants to get his part. If the branch doesn't get sun, it actually will sever the plant. You'll see dead tree branches. Well, that branch wasn't getting enough sun, so the tree made a decision. I don't know how it did it, but it made a decision to get rid of the branch. So it's really cool that we see the relationship to the human body and how our blood vessels work to nourish our entire body, to how a tree's root system has that same design to maximize the water intake, to the canopy of the tree, the tops of the tree, and how it spreads its fingers, all makes for why studying science is amazing, why studying life is amazing, because we see that there is this relationship between us and the environment. And you realize it more when you get out and you experience it yourself. You start to think, wow, that's amazing. Like this fern. Ferns don't have seeds, they have spores, so they're different. And so scientists tried to figure out, well, how are ferns different? And here's a fern right here. Ferns like shade. This whole canopy, or this whole forest floor, is a shade-loving plants. And they do rather nicely, but boy, the trees own the sunlight, and so these plants I've put here, but I know that they're shade lovers, and then they just take off, and the gardener gets the credit, but really it's the nature that gets the credit. The gardener just knows how to put the right plant in the right place, and so it can thrive. But yeah, these ferns are really cool. Love the shade, but they don't have seeds, they have spores. And these are called a fiddle, and these are actually edible. Right here, I could pick that. I'm not gonna pick it because I want it to be a fern, but those fern fiddles, when I was on a survival study in Wisconsin, we ate fern fiddles, but they produce differently. And it just shows there's so many differences we have woody plants like shrubs, and we have woody trees. Okay, there's differences. We also have broadleaf trees, and we have your monocots. And so the more we look, we look at the complexities of what's here. It's just amazing, and it just makes you want to learn more. Mr. J knows a lot, but boy, he hasn't figured it all out. I just know when I get here in the woods, I start asking lots of questions. Start thinking about cool stuff. So, all right, scientist, I'll see you.